Welcome to this video. On this video, we're going to talk about how do we find the area under a curve. Okay, you know how to find out the area of a rectangle, right? You know how to find out the area of a triangle, but we don't know how to find area of this shape, right? If you have one side irregular, we don't know how to find out the area here. So we use antiderivative to find out the area under this curve. Okay, so we use antiderivative for that. Okay, so before we start how to find the area under a curve, let's do some of the review on the how do we write the summation notation. Okay, the notation, so this notation, how do we write this? We write a line first and then do like that. Okay, so this notation is called sum notation. Summation we call summation. Okay, if there is summation, I runs from 1 through n, I equals to 1 through n means, and then if there is a sub I, then what we do is we write I equals to 1 and then write this is summation. So you write plus and then write I equals to 2 and then plus and continue that way, and then write up to the last value of I plus a sub n. Okay, this is how we write this is the expanded form of the sum. This is the shortcut or the summation notation, right? Sum using the summation notation. Let us see some examples. Number one is find I equals to 1 through 5, 1 over 2i plus 3. What we do is we write down I equals to 1. How much you get? 1 over 2 times 1 plus 3 is 1 over 5, right? Plus write down I equals to 2. What do you get? 1 over 2 times 2 is 4 plus 3 is 7. 1 over 7 plus. If you write down 3, you will get 1 over 9 plus. If you write down 4, you will get 1 over 11 plus. If you write down 5, you will get 1 over 13, right? And if you use calculator to find the sum, what do you get? The total sum of this will becomes is 0.6218. 0.6218. Okay, so on the second example, you have n runs from 2 through 4 and then n over n squared minus 1. You see that there is one n on the top and one n on the bottom there. So you'll have to plug in, when you plug in 2, you'll have to plug in both places, right? And then plus, and then plug in 3, and then plus, plug in 4, and so on. So let's plug in 2. What do you get? 2 over 2 squared is 4 minus 1 is 2 over 3, right? And then plus, so here is 3 over 3 square minus 1 is 3 over 8, right? Plus 4, plug in 4. 4 over 4 square is 16 minus 1 is 4 over 15. Okay, the value of the sum. So there are some formula, but before that, what we do is if there is a sum of a number constant k times the ai, what you can do is you can pull that k out. Okay, you can pull the k outside and then do the summation of ai only. That's what it says. And the next formula is if there is sum of two terms, ai plus bi, then you can distribute this sum to ai and then plus and then sum of bi. You can do that too. Okay, so these are the some basic rule of sum, but there are some more rules. If there is I equals to 1 through n, c, if you are adding a constant c and then n times, this is like c times n, right? This is the formula number 1. So if you are adding a constant, if you have a summation of a constant, it will be the what you do is when I is 1, it will be c. When I is 2, it will be c. So it will like c plus c plus c plus c plus c n times. So if you factor out c, then you will get 1 plus 1 plus 1 n times. So that is c times n. That's formula number 1. Okay. Formula number 2 is if you have a sum of I, that means you plug in 1 and then plus, plug in 2, plus, plug in 3, and then it is like 1 plus 2 plus 3 plus 4 plus 5 plus 6 and so on up to n through n, right? If you do that, then you will get the formula will be n times n plus 1 over 2. N times n plus 1 over 2. Okay, that number times that number plus 1 over 2. If there is I square instead of I to the 1, if there is I to the 2, it will be like 1 square plus plug in 2, 2 square plus plug in 3, 3 square plus 4 square plus 5 square, like that. If there are n many terms, then the formula is n times n plus 1 times 2n plus 1 over 6. And the fourth formula is IV is, if there is sum of the I cubed, that means 1 cubed plus 2 cubed plus 3 cubed, because the plus is from the summation, right? So 1 cube plus 2 cube plus 3 cube plus 4 cube plus 5 cube. If you are adding that n numbers, then it will be n squared times n plus 1 squared over 4. But you should be careful. All these sum formula, they starts with 1, right? You see that? 1, it starts with 1, start with 1. So you should have 1 plus 2 plus 3 plus 4 here. Here you should have 1 squared plus 2 squared plus 3 squared plus 4. Here 1 cube, 2 cube, 3 cube, like that. Okay? So in that case, you can use this formula to find out them directly. Okay? So let's do this problem. The first problem is summation of 2i squared minus 3. What we can do is, there is minus in the middle, so you can apply that. So you can distribute the summation. So what you can do is, you can write summation of 2i squared minus summation of 3, right? And if you simplify that, you can pull that 2 out, because that formula says that if there is a constant, you can take that out. So it is I equals to 1 through 5. We cannot forget that I equals to 1 through 5, right? So what do you get? You get 2 out, summation 1 through 5, and then I squared, right? And then minus, so what is the sum of the constant? Sum of the constant, C, is C times the n. What is n? N is 5 here, right? So 5 times 3. That's what you get, okay? Now, 2 times. What is the formula for sum of I square? Sum of I square is formula number 3. So n is 5 in our case. N is 5. So it is 5 times 5 plus 1 times 2 times 5 plus 1. It will look like this. N times n plus 1 times 2n plus 1 divided by 6. Minus 5 times 3 is 15, right? So now cancel 6 and 6. What do you get? You get 5 times 2 is 10 times 11 is 110 minus 15. That will be 95. That's what you get. Okay, so next example is summation of I starting from 1 through 10, 2i plus 7. What you can do is, you can pull that 2 out and give the summation to I only. I equals to 1 through 10, and then plus summation of 7, right? I'm distributing that. I runs from 1 through 10. You see that? So what do you get there? So it is 2. The sum of I is the second formula, right? So what it says is, if there is n, then n into n plus 1, n times n plus 1 over 2. So that is 10 times 10 plus 1 over 2, right? So 10 times 11 over 2. That's what you get. You cancel 2 and 2. And then plus, so it is 7. When I is 1, it is 7. And then plus 7 plus 7 plus 7, it is 10 times. So it will be 10 n times c, right? 10 times 7. So what is the final answer then? Your final answer look like 10 times 11 is 110 plus 70. That will be 180. That's your final answer. Okay, guys. The last one is I minus 1 square. We don't have a formula of I minus 1 square, but we have formula for I square and then I. So what you do, you just FOIL this. It is I minus I times I minus 1. Let me write down that. So it is I starting from 1 through 7. I minus 1 through times I minus 1, right? So if you do I minus 1 times I minus 1, you do FOIL. I times I is I square. I times negative 1 is negative I, and then negative I, another negative I here, and then plus 1. So it will look like this. Summation of I runs from 1 through 7, and then you write I square minus 2i plus 1. You see that? Now you distribute that summation to all of them. So what you get here is equals to summation of I runs from 1 through 7, I square, right? And then minus 2, sum runs from I from 1 through 7, I, and then plus summation of I runs from 1 through 7, 1, right? So what is the first sum? The first sum is I square, the formula of I square, right? If it is n there, then n times n plus 1. But we have 7 here. So 7 times 7 plus 1 is 8, times 7 plus, times 2 plus 1 is 15. So you get 7 times 8 times 15 divided by 6. That's what the formula, right? And then minus 2 times. What is the sum of I formula? It is n times n plus 1 over 2. But what is our n? 7. So 7 times 8 over 2, right? And then plus sum of 1 7 times, right? 7 times 1. So because the formula is C times N. So what you get here is, if you use calculator, you will get so the answer is 91 here. Let's see one more example there. Write using the sum notation. So here this summation notation was given and then you were expanding that and finding the sum. But here you want to write using the sum notation only. Let's see how do I write this using the summation notation. So here let us first find out what number is not changing, okay? And if something is changing, we will write that as I. So 7, 7, 7. So 7 is not changing. Let me write down summation here. And then there is 7, right? And then parenthesis. In each of those brackets, there is a parenthesis. So the bottom number on the parenthesis is 6. So what we do is you write down 6 there. And the top number is, on the first bracket, there is 1. On the second bracket, there is 2. On the third bracket, 3. And then on the sixth bracket, there is 6. So what I would write is, I write I. And then close the parenthesis. And 5 is not changing in any bracket, right? So plus 5. That's what it looks like. And how is that I? I is running from 1 through 6. You see that? When you plug in I equals to 1, you will get 7 times 1 over 6 plus 5. That's what you get. For I equals to 2, you will get 7 times 2 over 6 plus 5. That's the second one. And similarly for the 6, 7 times 6 over 6 plus 5. So this is the summation notation. Okay. So if you want to find the sum, how do you find the sum? What you do is, because this is 7 over, because this is 6 is a constant, you can pull that out. 7 over 6, you can write 7 over 6 and then summation I runs from 1 through 6 and then plus summation I runs from 1 through 6 and then 5, right? So how do you do that? This one will become 7 over 6, right? So what is the formula for summation of I? It is n times n plus 1 over 2, but here is 6, right? So it will be 6 times 7 divided by 2 plus this is n times c, right? So it is 30. So what do you get? You get 6 and 6 cancel out. So 7 times 7 is 49, right? Divided by 2 is 24.5 plus 30 is 54.5. That's what the... So that was some basic about the sum notation, basic review. Now what we do next is area under a curve in the interval AB. Suppose there is a function y equals to function of function of x, y equals to fx, okay? Suppose there is y equals to fx is a function. Now you want to find out the area under this curve between a and b. X equals to a, this is x equals to a, and this is x equals to b. So you want to find out the whole area under this curve. If it was a rectangle, you could use length times the width, right? If it was a triangle, we have the formula for that. But this is not a triangle or rectangle. This is like one side is just a curve. So I want to find out the area under this curve, okay? So there are several techniques to do that. We may not be able to find out the exact area, but we will be able to find out or approximate the area, okay? So how do I do that is, first we divide the interval AB into n equal parts. So what we do is, between A and B, I divide them into n equal parts. N can be anything, okay? It can be 100 or 1000 or 10,000 like that. But for now, this is just, I'm just giving you the concept behind that. Suppose we are dividing the interval AB between n equal parts, and suppose the length of each of these piece is delta x. Okay, this is delta x, this is another delta x, this is another delta x, this is another delta x, and so on. So how much is the total length? Can you tell me what is the total length? The total length will be b minus a, right? Because this is 0, right? So the total overall length is b, and then minus a is this length is b minus a. So how many pieces are you breaking that length b minus a? Into n pieces, right? So n pieces, we divide by the total length by the n, will give you the delta x. Okay, but I will show you another way to get the delta x differently too. But let's see the here. So what I did here is, I'm trying to find out the area under this curve. Okay, what I did, I divided this interval AB into n equal parts. such that each a piece, this piece has length delta x. Okay, there are so many of these, and this one is also delta x. Now, so for each of those pieces, draw a line to the curve. Draw a vertical line that touches the curve for each of these boundary of the pieces. Okay, next what we do is we will complete this rectangle. Okay, how do I complete the rectangle? One time with this orange color. Okay, at the for the first time with this orange color, what I do is I will draw a rectangle like this with this orange color, right? You see that? And then that is the rectangle I'm drawing. This is the rectangle. And this, so what I'm doing is for each of those pieces, I want to complete the rectangle. So when I complete the rectangle, there are two ways. For this area, you can take the height of the rectangle this side. In this way, you see that the orange color, this is the height of rectangle. This left side is the height of the rectangle I'm taking. Okay. And for this one, the left side is the height of the rectangle. You see that? This is the rectangle you get. For the second one, for the second piece. For the third piece, the height of the rectangle, the left side is the height of the rectangle I'm picking on the left side every time. Okay. So we call left sum or the lower sum. Okay. Left sum is you complete the rectangle by taking the left side as the height of the rectangle. Okay, for each of those, see what happens in the last one. Last one is the left side is taller than the right side. Okay, when you do that, the height of the rectangle will start from the top like that. You see that? Okay, so let us find out area of each rectangle. So what is the area of this rectangle? The height times the width. So delta x times, what is the height of this? So this is a, right? So this is function fx. So what is this height? Fa. You see that? So a. So this is a. This is fa. So the area of this rectangle is delta x times fa. This is the area of the first rectangle. You see that? Delta x times fa. Similarly, for the second rectangle, what is the value of this point? This point is this length was a. This is delta x. So this is a plus delta x. You see that? A plus delta x. And what is the height? Height is f of a plus delta x. So what is the area of this rectangle? It is delta x times f of a plus delta x. You see that? Delta x times f of a plus delta x. That's what you get, right? Similarly, what is the area of this rectangle? Taking the left side as the height. So this point is a plus 2 delta x because a delta x plus delta x. So it is a plus 2 delta x and the height is f of a plus 2 delta x, right? So this area of this region is delta x times f of a plus 2 delta x. You see that? Delta x times f of a plus 2 delta x. Similarly, the last one, what is the height? We are taking height as the left side, okay? So the height is, can you tell me how much is that? And how much is that basically? So you are making n delta x's there, right? N pieces, meaning n of them are delta x. So it is a plus n delta x, right? B is basically a plus n delta x. You see that? So what will be this one? The one before that b is a plus n minus 1 delta x, right? Because before 3 it was 2, before 2 it was 1, like that. So a plus n minus 1 delta x is this. So the height is f of a plus n minus 1 delta x. This is the height of the last rectangle, and then delta x is the width. So this is how you get the sum of the areas of those rectangles. Now if you write in this summation form, what do you get? So here I'm writing f of a plus I delta x. At the beginning, which is delta x times f of a, right? So when you take I equals to 0, you will get delta x times f of a. And I equals to 1, you will get delta x times f of 1 times a plus 1 times delta x. It will be a plus delta x. For I equals 2 and so on. So it goes through, and then at the end you go up to n minus 1. You see that? You got n minus 1. That's why you can write I equals to 0. I'm starting from 0 because at the beginning there is no delta x. I times delta x is 0 times delta x there, right? So it starts from I equals to 0 and go up through n minus 1 and delta x times f of a plus I delta x. This is what we get. So here it is called lower sum or left sum. Left sum. Okay, lower sum or left sum. So another one is, we do the same thing, but every time you find out the area of a rectangle, you take the height as the right side. Okay, so we will take the height as the right side. You see that the green color there. For the first rectangle, the width is delta x, right? But the height is the right height. You take the right side as the height. So if you complete the rectangle and then color this is what you get. You see that? So all these sides. So what is the area of the first rectangle? It is delta x times f of a plus delta x. That's the height, right? The height is f of a plus delta x. So you see that? Delta x times f of a plus delta x. Similarly, for the second one, the width is delta x again. The height is, we don't take the left height, we take the right height as the height of the rectangle and complete the rectangle. And then the overall area is the area of that rectangle, right? So what is the area of this rectangle? Delta x times f of a plus 2 delta x. You see that? Delta x times f of a plus 2 delta x. And continue with that. And at the end, on the last rectangle, since you are taking the right side as the height, right? You go up to here only, and then this just below that is basically the region of the rectangle here, just below that point. Okay, because we are taking the right side as the height. So what is the area of this? Width is delta x. Width is the delta x there, delta x, right? And then what is this one? So what is the height of this? This height is f of a plus n delta x, right? That's what you get. So that's what I read, f of a plus n delta x. Now I want to write in the summation form. I equals to 1 through n. So all of them have delta x. All of them have a. Plus, what is changing is this number. There is 1, there is 2, there is 3, 4, and then there is n. So there is I. That's what I wrote. I runs from 1 through n. A plus I times delta x. So now look at this. Another way of finding the value of delta x is, here you have the b is basically a plus n times delta x, right? Because this is a and then there were n delta x added to get b. So a plus n times delta x equals to b. Now if you solve for delta x, you subtract a on both sides, right? So you get b minus a and divide by n. You will get b minus a over n is the delta x. We will need this formula, okay? We will need this formula to find out the delta x later. So let us do one example here. I want to do one example. What example says here is, find the left sum and the right sum. So we call upper sum or the right sum here, okay? So this is left sum, or this is upper sum or right sum. Right sum, because we are taking right side as the height there. Okay, now you want to find out the left sum and the right sum of this function. Fx is 2x squared plus 1, okay, and on the interval 0 to 1 using 5 rectangles. You want to make 5 rectangles, we will use this value as the left sum and the right sum, okay, or the lower sum and upper sum. Okay, so how do I do that? So here, solution. So tell me, what is A? A is the left side of the interval, which is, this is A, this is B, right? A is 0, B is 1. So tell me what will be delta x. What is the formula? B minus A over n. So how many rectangles you want to make? 5, right? So it is 1 minus 0 over 5. That is basically 1/5, or you want to write 0.2. That is the delta x. So each of this width will be 0.2. Okay, so what you have to do here is to find out this left sum. Let's find out the left sum here. L equals to summation I runs from 0 to n minus 1. What is n? Let me write that n. So I equals to 1 through 0 n minus 1. That will be 5 minus 1 is 4. You see that? And delta x is 0.2, and then f of 0 plus I times 0.2, right? You see that? And then close that. So how that look like? So you write I runs from 0 to 0 to 4. So this is I runs from 0 through 4, you see that? And then 0.2 times f of 0.2i, right? You see that? 0.2i. So what is fx though? So fx is 2x squared plus 1. So how do I write that? Is summation I runs from 0 to 4, right? And then I would write 0.2 times 2x. X is 0.2i, right? So 2 times 0.2i squared plus 1. You see that? So how do I write that one then? So let's simplify. Summation I runs from 0 to 4. You see that? 0.2 times. So how much is 2 times 0.2i times 0.2i? If you do 2 times 0.2i times 0.2i, it will be like 2 times 0.04i square. That's what you get. Because 0.2 times 0.2 is 0.04 and I squared. And then plus 1. So what I'm going to do next is I runs from 0 to 4. And I'll just simplify this, okay? So 2.04 will be 0.08 times 0.2 will be 0.016, I think. So 0.016 I square. You see that? And then plus, how much is that? 0.02. 0.02. That's what you get. Okay, guys? Because it is 2.04 will be 0.08 times 0.2 will be 0.016, and there is I square and then plus 1, but you need to distribute that 0.2 to both of this one and that one. You got that one. Okay, so next what we do is we distribute the summation to both of those. So this will be this is equals to summation of 0.016 I square, okay, plus summation of I equals to 1 through 4, 0.02. You see that? So this will become, you pull that 1 through 4, right? So I runs from 1 through 4, 0.016. So this is I square. What is the formula for I square? It is n times n plus 1 times 2n plus 1 over what? N times n plus 1 plus 2n plus 1. Oh, I'm sorry. This is 0 through. Okay, so what do I do next is I just distribute this sum to this first term and then the second term. This is what you get, okay? 0 through 4, 0.016 I square plus, and the sum give to the second term, I equals to 0 through 4, 0.02. What I'm doing next is I want to pull this to the front because this is a number, right? And then keep I square inside. So what do I get is this. So you get summation 0 through 4, I equals to 0 through 4, I square, and plus, so what is n? N is 5. Why? Because you are starting from 0, right? I equals 0 and then 1, 2, 3, 4. The total is 5. So it is, this is the constant. Sum of the constant is n times c. So the 5 times 0.02. You see that? So if you simplify this, you'll get 0.016 times. So n is 5, right? Again. So what you do here is, but do you know that because the summation formula that starts with 1, right? But here we are starting from 0. So what do? Is I plug in 0. If I plug in 0 here, you will get 0. But here if I plug in 0, you will get 0.02 because there is no I. Okay. So here it starts from 0 or starts from 1. It does not matter. You will count how many are there total. But here you don't have to worry about 0. Why is that? Because the first term is 0. 0 will make it 0 square. The second term will be 1 square, and then third term 2 square, like that. So you will write like this: summation I runs from 1 through 4 and then I square plus this is 1, right? So why I did I 1 through 4? Because when you plug in 0 and here you will get 0. That's why I can start from 1. Okay. So 0.016. What is the formula? Here there are only 4 terms, right? 1, 2, 3, 4. That's why 4 times 4 plus 1 times 8 plus 1, 2n plus 1 over 6 plus 1. You see that? So this will become 0.016 times, and then what? Then you'll get 4 times 5 times 9 divided by 6. You see that? Plus 1. If you simplify this, basically you will get 1.48. If you simplify, you use calculator, you'll get 1.48. This is the left sum of the rectangles with taking the left side as the height of the rectangle. So how do I find out the right sum? So what is the formula for R? The formula for R is summation, right? It starts from I equals to 1 through n, right? N is how many n? N is 5 here. You see that? So the left sum starts from 0 through 1 less than the number of rectangle, that is 0 through 4. But here it is starting from 1 through 5n, right? And then it is, the formula is delta x times f of a plus I times delta x. Okay, this is similar to the previous one, okay, except we start from 1 and then go through 5. So what is the value of delta x? We got a delta x is 0.2. So we write 0.2 summation 1 through 5, 0.2 times f of a is 0, I and delta x, so 0.2i. You see that? Similar as above, what do you get? If you simplify this, summation 1 through 5, 0.2, that will be, so plug in, it is similar to that one, right? Plug in f of 0.2i for x. So what we do is x equals to 0.2i. So if you do that, you will get 2 times 0.2i squared plus 1. What do we get here ultimately? You got basically, you can plug in here this thing here, 2.2 times 0.2i squared plus 1. You see that? And then summation 1 through 5, 0.2 times, this will be 0.08i squared plus 1. Okay, that's what you get. And then if you simplify this, you will get summation I runs from 1 through 5. I runs from 1 through 5. So 0.016i squared and then plus 0.0. So all of these must be 0.2, not 0.02. So this must be 0.2, 0.2. All these must be 0.2. All right, the answer is correct though. Okay, so this must be 0.2 as well. .2, like that. Now you distribute the summation symbol. So what do you get? If you distribute that, you will get the summation. What you get there is summation I runs from 1 through 5, 0.016 I square, right? And then plus summation I runs from 1 through 5, 0.2. So this is sum of the constant. The formula says that this is 5 times 0.2. That will be 5 times 0.2, right? So that will be 1. You see that? And for the first one, you can pull that out, 0.016 out, and then find the do the I square 1 through 5, right? What is the formula for I square? It is n times n plus 1 times 2n plus 1 over 6. So what is n? N is 5. So 0.016, and then 5 times n plus 1 is 6 times 2n plus 1 will be 11. You see that? Over 6, and then plus 1 there, right? So what do you get? If you simplify this, you cancel 6 and 6, and if you simplify this, your answer will be 1.88. So what was our left sum? the left sum L was 1.48 and the right sum R is 1.88. But you know that when you approximate the area under the curve, right? Sometimes you take the left side as the height, sometimes you take the right side as the height. You see that? This is the rectangle with the left side as the height. You see that? And sometimes you take the right side as a height. When you take the left side as a height, and if you sum all those areas, so it will give you approximate the area under the, it will approximate the area under this curve. But it will miss some of these, right? You see that? This part is missed. Similarly, if you take the right side as the area, if you take the right side as the height, okay, for example, for the first, this is the total area, right, of the first rectangle, and this is the total area of the second rectangle. This is the total area of the third rectangle, and this is the total area of the fourth rectangle. If you do that, it is overestimating the area, meaning it will give you the more area than the actual area of the rectangle. So both of them, sometimes the left area is smaller than the right area, sometimes the right area is smaller than the left area, because it depends on how the graph of the function is, right? If your function has this type of graph, then the left area will be like this. You see that? So the left area, taking left side as the height, it will become like this. This is the left area. This is the left area for that, and another one has, this is the left area, right? But if you take the right area, it will be like this. You see that? This is the right area for this first rectangle. This is the right area for the second rectangle. So it depends. Sometimes the function has the left area bigger than the right area. Sometimes the right area is bigger than the left area. But it looks like none of these left area and right area is giving the exact value of the area under the curve, right? Sometimes what we do is, we call the mid area. What we do is, to take the height of the rectangle, instead of taking the left area and the right area, okay, instead of taking the left area and the right area, what people do is take the midpoint and then take the height and then think that as the area of the first rectangle. Although the area of the total area is like up to here, right? And for the second rectangle, take the midpoint here and take that as a height and then complete that like this, okay? So this is the area of the second rectangle and so on. So sometimes this gives you the better approximation of the area. So basically it will have less error than the mid area will give you the better approximation, okay? For the mid area, take the midpoint and then take the height at the midpoint and take that as the height of the rectangle. Okay guys, so sometimes we do that, but in all these cases we divide the rectangle into equal pieces, right? So equal piece, delta x, delta x, delta x, like that. Okay, so in the next section you will see the Riemann sum. Instead of left sum and right sum, we take the Riemann sum, meaning that you don't have to have the equal width of the smaller rectangle. We can have the bigger sum width are smaller, which we don't cover in detail because of the time, okay? But I will try to go over very quickly on that. Okay, so this is how we find out the left area and right area of area under the, for the area under the given function. Okay guys, thank you.